This is geometry, section 12.4, angles formed by chords, secants, and tangents. So we start with a theorem, more about these three things that we've been learning about all of this chapter that have to do with circles. So the first one says if a chord and a tangent, so a chord is a segment inside a circle and points on the circle. A tangent, again, is a line that touches the circle once. So if a chord and a tangent intersect on a circle, then the angles formed, so angles 1 and 2 in this example, are equal to half of the intercepted arc. Oops, arc is already here. Intercepted arc. So in other words, the measure of angle 1 would be equal to half the measure of this arc, A. So it's going to be half of A. And then the measure of angle 2 is going to be half of this arc right here, B. So an example. If we're looking for this angle A right here, or how many degrees this angle is, it's a chord and a tangent, so it's going to be half of this arc right here, which is 174. So we take 174 divided by 2, we get 87 degrees for A. Same thing here, except now it gives us this arc. We need to figure out what this arc is, because angle B is opening up to this arc right here. So to find that arc, we need to take the entire circle minus the piece that it gives us. It's on the opposite side. So when we do that, we get 232 for this arc right here, which means this angle is going to be half of that. So we divide it by 2, and we get 116. Over here, now we're going backwards. So it says this angle is 112. So now we're going to have to double it to find this whole arc right here. So when we double that, we get 224. Now to find C, that's the rest of the circle. So we have to take the entire circle, subtract the piece that we don't want to find the piece that we do want. So 360 minus 224 gives us 136. All right, so when two chords go through the center of the circle, everything is balanced, for lack of a better word. So if we've got this right here, this is a diameter. This is a diameter. When two chords go through the center of the circle, they're diameters. Okay, so if this is a straight line, then these two arcs together equal 180 degrees. So if this one's 110, this one has to be 70. That would mean the central angle is 70. This is a vertical angle, so that's 70, which makes this arc 70. Same thing over here. This central angle is 110. That makes this 110, which makes this arc 110. So everything is sort of balanced all the way around. The opposites are the same, and the ones next to each other are supplementary. All right. But sometimes chords are not going to meet at the center, and it's not going to be that easy. So when that happens, if two chords intersect inside a circle but not at the center, then the intersection angle, so this angle right here, which is going to be the same as this angle right here, so the intersection angle, whichever way you want to look at it, because they're vertical angles, so they're going to be the same, that angle is equal to half of the sum of the intercepted arcs. So if two chords intersect inside a circle, then they're going to intercept two arcs together. This arc right here, this arc right here. A and B is what they're called here. So the measure of angle A is going to be half the sum, which means I add them together, the intercepted arcs, A plus B. So if A was, let's say it's 50 degrees and B is 60 degrees, we would add 50 and 60, that would be 110, and then we would take half of that, which would be 55 degrees for angle 1. So another example of that, we're trying to find H. We've got two chords intersecting inside the circle, so to find H, we take half of the intercepted arcs, 60 plus 80. 60 plus 80 is 140, and half of that would be 70. If this is 70, H and K are supplementary. They're on a straight line, so I subtract 70 from 180 to get K, and I'm left with 110. All right, for this next one, starting with W, we have to add the intercepted arcs and then take half of it. So 130 plus 40 is 170. Half of that is going to be 85. And then again, if W is 85, V is supplementary to it, so 180 minus 85 leaves me with 95. All right, for this one right here, it's a little bit more complicated. Now we're given the inside angle, we have to find one of the outside arcs. So we know that this angle, the inside angle, is going to equal half of the sum of these two arcs. So we just write that all out, plug it in the formula. This angle equals half of this angle plus this angle. The inside equals half of the two outsides added together. So if we distribute this 1/2, the 80 stays the same. Half of 130 is 65. And then it would be times 1 or plus 1/2 x. We would subtract the 65. 80 minus 65 is 15. So then that equals 1/2 x, because this cancels out. When we divide by 1/2 or multiply by 2, we get that x equals 30. And if we check that, if we plug it in, 130 plus 30, outsides added together equals 160. And if I take half of that, I do get 80. All right, same thing over here, except now it gives us the supplementary piece. We have to find this piece. So if this is 80, this has to be 100 because they have to add up to 180. So same thing. Inside equals half of the outsides added together. So the outsides are 90 and x, or 90 and y, sorry. All right, so we've got 100 equals half of 90 is 45 plus half of y when we distribute the 1/2. Subtract the 45, we get 55 equals 1/2 y. So we multiply it by 2 to cancel out the 1/2. 2 times 55 leaves us with 110. All right, last theorem. So we just had if two lines intersect inside a circle, then we take half the sum of their intercepted arcs. But if two lines intersect outside of a circle, so it could be a secant and a secant, a tangent and a tangent, a secant and a tangent. Any combination of any of those lines that are going outside a circle, not just chords which stay inside the circle. Okay, so if that happens, then the angle formed by those two, so this angle right here, this angle right here, this angle right here, the angle formed when those two lines intersect is equal to half of the difference now of the intercepted arcs. So when the lines are intersecting inside the circle, you take the sum of the arcs. When the lines are intersecting outside the circle, you take the difference of the arcs, which means subtraction. So for all of these examples, measure of angle 1, the angle where the lines intersect is going to equal half of the bigger arc minus the smaller arc, B minus A. So we'll see what that looks like down here. So if I'm trying to find for the first one, if I'm trying to find the measure of A, I take half of the difference of 110 and 30. So half of 110 minus 30. 110 minus 30 is 80. And then half of that would be 40 for angle A. Same thing over here. If this is 50, this is 170. I have to subtract those. That gives me 120. And then I need to take half of that to find the measure of angle B, which would be, whoops, not 80, 60. Okay. This one is similar to the last two that we did up above. We have to write out the entire formula. So this angle, the outside angle, equals the two arcs subtracted from each other, and then half of that. So C is definitely the bigger one. So we want half of C minus 40. We need to figure out what C is. 30 stays the same. Now I distribute the 1/2, so 1/2 C, half of 40 would be 20, and it's subtraction, so we have to bring that down as well. So now I add 20 to both sides. 30 plus 20 is 50, equals 1/2 C, and then to get rid of the 1/2, I multiply by 2, so 2 times 50 would be 100. If we checked that, 100 minus 40 is 60, and half of that is 30. All right, a few more. Same thing, so we've got the outside angle, the intersection angle equals 1/2 of the bigger angle, which is 140, minus the smaller angle, which is D, which we're trying to find. So 30 equals half of 140 is 70 minus 1/2 D. So we subtract 70. 30 minus 70 is now negative 40. but we have a negative 1/2 over here, which means to get rid of it, we would have to multiply by a negative 2. So when we multiply negative 40 by negative 2, we get positive 80. And if we check that, 140 minus 80 is 60, and half of that is 30. All right, for this one over here, we're only given one number, but since we've got two tangents, if this is 250, then this piece is just the rest of the circle. So we could take 360 minus 250, and that would give us 110. So now we just take 250 minus 110, the difference of the two arcs, and then half of that to find angle E. So 250 minus 110 is 140, and then half of that is 70 degrees for E. All right, letter F, most complicated one on here. So we've got lines intersecting inside the circle and outside the circle. Okay, so we can start with these inside angles. Okay, so we know that these are each 60, and we know that the inside angle when two angles intersect, or sorry, when two lines intersect inside a circle, that's going to equal half of the sum. Remember, when it's inside, it's the sum of these two arcs. So to find x, we could set this up as 60, the inside angle, equals half of 70 plus x. So when we do that, 60 equals half of 70 is 35, plus half of x. When we distribute, subtract the 35, we would get 25. When we subtract 35 from 60, equals 1/2 of x. And then we multiply by 2 to get rid of it, so x would be 50. So x is 50. Now we need to find y. So we have this outside angle, which is going to equal half of 50 minus y, because when the lines intersect outside the circle, it's the difference. When they intersect inside like this, it's the sum. So same thing, distribute. Half of 50 is 25 minus half of y. If I subtract 25, I get negative 10. This cancels, negative 1/2, so I would need to multiply by a negative 2. Negative 2 times negative 10 would be positive 20.